Oh, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant, and we are looking at question 21 from the 2022 Pascal contest. So this one gives us this diagram on the right, and I've provided us the diagram on the left below for us to work on. But we're asked to consider a pegboard like this. This one is 5 centimeters by 5 centimeters, and then there are holes every centimeter from the edge in a grid. Okay, so one thing that you could do is just like draw on this one. Okay, so there's 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters. Indeed, that's 5 centimeters, right? And then we would have a grid this way. And so you'll see that we end up with like a 4 by 4 grid on this 5 centimeter thing. And it can be really tempting to want to say we're going to have an 8 by 8 grid when we go to 10 centimeters by 10 centimeters. But we won't. It'll still be 9 by 9. It's still just one less. You don't want to get fence posted here or to forget to count the first thing, which actually happens kind of at 0. Okay, so I'll show you here. If we look at this one, we'll just go bigger so that I can make good sized dots. We are going, and in this question we're told that there's pegs on all the diagonals. Okay, so let's mark our pegs on this one here. And you could use graph paper on this contest too. So here's the diagonal. It's going to be here. Boop, 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 boop. There's that diagonal. And then this diagonal would also have pegs on it. Oh, look. There's one peg that I bet a lot of students counted twice in the middle. Okay, that peg in the middle, that 5, 5, it only happens once. So there's something different that happens on an odd size board rather than an even size board, where an even size board they don't intersect, they dodge each other. But here they land at the same spot. And then if we look at the other colors that are available, like we have pegs here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Wait, was that? Did I say 16? 16, and there's four triangles, right? So 16 times 4 is 64. This is one way to solve it, right? It would be to just count one of those triangles and know you had 4 such symmetrical triangles. Oh, and I have an extra peg up there that shouldn't be there. That's actually the edge of the board. Okay, so that's one way. 16 here. There's going to be 16 here. There's going to be 16 here, and there's going to be 16 here. Okay, so 16 plus 16 plus 16, therefore there are 64 pegs. Just like that. That's one way to do it. Another way, actually that's not the way I did it on the contest. I said, I think it's easier to know that there are 81, being 9 squared, little holes. Like this is 9 by 9 here, and every one of those points has a hole, so there's 81 in total. How many pegs were there? Well, here's 9, and then here's 8. There's 4, and there's 4, so 8. Okay, so I did it this way. I did it 81 minus 9 minus 8 equals, you guessed it, 64. So there's a few different ways to do this. I think visualizing it is almost a must, as well as looking carefully at the example they give you and seeing that this 5 centimeter by 5 centimeter grid has a 4 by 4 grid of pegs, and just committing to that as like, okay, I know that this 10 by 10 grid will have 9 by 9 pegs, or 81 total, and then figure out how many are in that cross. And being very careful here not to double count that peg, because it only happens once, even though it's in both diagonals. There's not 18 pegs, there's only 17. Okay, so I hope that's helpful. I hope that helps you solve similar questions like this in the future. And if you have any questions, hit us up in the community. That's it for me for now. Bye for now, everyone. Thanks so much for showing up for your learning.